Recorded is rolling. It is Thursday, December 15th. Right, so just got a few things lined up for you guys here. You guys know we're getting close to the Spirit Week. We got some fun holiday characters today, and tomorrow's pajama days. Speaking of tomorrow, you guys know we're going to be on this weird schedule tomorrow where you're going to have 18-minute classes. And actually, your lunch is going to be with your sixth period teacher. So you guys going to check with your sixth period teacher today, see what lunch you're supposed to be with. Okay. And then, of course, next week are these. Got 3 days, 2 classes each. Okay, so yeah, today's actually a really good opportunity to double check focus, make sure you got all your grades in, study for midterm. Yeah, anything you need to clean up will be mostly an opportunity. We got some board games and Legos for you guys. You guys know, of course, your very first exam is tomorrow, and that is seventh period tomorrow. Okay. All right, but the other main thing I got for you guys today is a huge science story. So let me switch my screen over. Screen 2. Yeah. All right. So talk about energy a bit. So there's energy from the electric grid that is powering. Oh, let's see the lights in here, the air conditioning, the projection that you guys are seeing this visual on. Okay. So I'm on EPA.gov, and for the state of Florida, most of that energy is coming from natural gas. That's what this orange bar is. Okay. And then this top line is for the entire United States. So entire United States split about half natural gas. And then for Florida, it's like mostly natural gas. We get some nuclear, that's this purple bit, some coal, that's this gray bit, and then like trace amounts of other things. Okay. So each energy source has different advantages and disadvantages. Natural gas is a type of fossil fuel, and fossil fuels, of course, have greenhouse gases associated with them. So yeah, that's contributing to global warming, not good, and also ocean acidification, the whole deal. Methane is one of the main constituents of natural gas, and that is something like 20 or 30 times as powerful as carbon dioxide in terms of the energy it'll capture and store. Right. So what's the way out of the climate crisis? Well, a lot of it involves energy source, like what source of energy are we using, and what's the best in terms of that? Well, probably the best option we have going today is like fission energy, like nuclear energy fission. But of course, nuclear energy, fission energy has its own associated problems. One is that, like, what do you do with the waste? Well, you have to store it, but then for what, like tens of thousands of years, because it has these long half-lives. And then how do you communicate with people tens of thousands of years from now? Like, oh, like avoid this particular place. Like we've never communicated like that long into the future, so it's kind of an unknown there. Also, every once in a while, there's some meltdown. You guys have probably heard things like 3 Mile Island, or Chernobyl was a huge disaster. Fukushima about 10 years back. And so every once in a while, something might happen like that. So there's no like perfect solution, but there is one that's making huge strides recently, and this is fusion energy. So this is also nuclear energy, but it's a different kind of nuclear. Actually, it's a much cleaner kind of nuclear. So the nuclear that we're using right now in power plants is fission, and that involves taking heavy atoms like uranium and splitting them. Okay. And then what happens is when you split a uranium atom, actually some mass goes missing. Right. Now, you guys know the Einstein equation, E equals mc squared? Okay. That is a mass energy equivalence formula. So if you look at the difference in mass from a nuclear reaction, it doesn't just disappear into nothing. It actually converts into energy. And then we can use that energy, put it on the grid. And some of it's power in this room right now. But there's another type of nuclear fusion that involves fusing together small atoms like hydrogen into helium. And from that, you can actually get like hundreds of times the energy that you can from fission, like almost 1,000 times the energy. Actually, we do have an application of fusion that's been around for a few decades, and that's nuclear bombs. So if you ever hear about a hydrogen bomb, also called a thermonuclear bomb, those bombs are hundreds of times stronger than anything that we dropped on Japan at the end of World War II. But can we control a fusion reaction and use it in a power plant, right? So make it commercial for energy? Well, we haven't been able to. But just in the last few days, scientists over at Lawrence Livermore Laboratory, this is over in San Francisco, were finally able to get a net energy production from these fusion reactions. So they have been running fusion reactions for a while, but the catch is that there's so much energy that goes into making it. There's more energy that goes in than they get out from it. Right? think they're using lasers over in Lawrence Livermore. This is funded by federal dollars, so money from the federal government. And what was this reaction look like exactly? Well, looks about like this. So there are these different isotopes of hydrogen. You guys know different isotopes have different numbers of neutrons. Okay? I think it's called deuterium and tritium. And this is so abundant in the ocean that once this is mastered and commercialized, which now looks inevitable, it's just, I mean, it'll be a matter of time, right? There's still a lot of research and development that has to go into this, and we have to build these plants and scale them up, right? But this right here, what you guys are looking at, is probably one of the biggest stories of this entire century, because this is really what's going to save us from the climate crisis. Right? So there is enough abundance of just these isotopes of hydrogen in the ocean that we could pretty much just run our entire energy supply from here on to the end of Earth just by ocean water. So anyway, really good news here. This is, again, like one of the biggest stories of the entire century. All right, so right there. So good news. All right, so switch back over here. Give you guys the rest of the class period to study anything you need to study, catch up on anything you catch up on. If you're missing anything, turn it in. And you guys also have Legos and board games, so enjoy. Make the best use of your time.